Euler's identity is often cited as the most beautiful equation in mathematics because it seamlessly links five fundamental constants. However, seeing it written down algebraically often hides the stunning geometric intuition behind it. To truly understand why e to the power of I times pi plus 1 equals 0, we must move beyond algebra and visualize this on the complex plane. Start by picturing a standard two-dimensional grid. The horizontal axis represents the real numbers we use every day, while the vertical axis represents imaginary numbers. We begin our journey at the number 1 on the real axis. Visualize a vector or an arrow stretching from the center origin out to the number 1. This is our starting position. Now, consider the term e to the power of I times x. In the world of complex geometry, this term is not just a number, it is an instruction for rotation. Specifically, it tells us to rotate around the unit circle with a radius of 1. The number in the exponent tells us the angle of that rotation in radians. In our specific case, the exponent is pi. We know from basic geometry that pi radians is exactly equivalent to 180 degrees, or a semicircle. So, watch as our vector at positive 1 begins to move. It does not shrink or grow, it stays exactly 1 unit long. It rotates counterclockwise, tracing a perfect arc along the upper half of the complex plane. As the angle increases, the point travels along the circumference of the unit circle. When the rotation hits exactly pi radians, the vector has swung all the way around to the opposite side. It lands precisely at -1 on the real axis. This visual demonstration reveals that e to the power of I times pi is actually just a coordinate location equal to -1. Finally, look at the last part of the equation, which tells us to add 1. Geometrically, adding a real number is a translation or a slide along the horizontal axis. Since we are currently sitting at -1, adding 1 means we slide the point 1 unit to the right. As you watch this translation, the point arrives perfectly at the origin, which represents 0. Thus, the equation describes a journey. Start at 1, rotate half a circle to -1, and step back to 0. If you enjoyed this explanation, hit subscribe and check out our other math videos.